Hi everyone. So today we are going to basically just be reviewing, going over some stuff we haven't talked about in a little bit, especially the do now. So I want you to find the limit of the difference quotient. So remember that's your limit as h approaches 0 of f of x plus h minus f of x all over h. So pause the video and try that one. So I have my limit, h approaches 0, 2 over x plus h plus 5 minus f of x, 2 over x plus 5, all over h. So when we have fractions, we need our common denominator, x plus h plus 5 over here. Whatever we do on the bottom, we do on the top. And over here we have x plus 5, x plus 5. All right, so let's see. I'm just going to work on that numerator. So I get 2x plus 10 minus 2x minus 2h minus 10. So we end up canceling out the 2x's and the 10's. And usually that happens. You're only left with the thing with the h on top. So limit as h approaches 0. So I have 2h all over x plus h plus 5, x plus 5. And then don't forget this h just goes into the denominator. Dividing by h is the same as multiplying by 1 over h. So then the h's cancel, right? This h and this h cancels. So then I can plug 0 in, and I get negative 2 over x plus 5 times x plus 5, which is negative 2 over x plus 5 squared. Okay. All right, pause the video and try these. So it says the graph of f has the graph of f shown below has vertical asymptotes at x equals 3 and x equals 6. Find the following limits. Use infinity or negative infinity when appropriate. So let's see, 3, here's 3. From the left is going up, so it's infinity. From the right, it's going down, negative infinity, which means the limit does not exist. 6 from the left is negative infinity, right? Going down over here. From the right, it's also going down, which means the limit is negative infinity. The limit as x approaches infinity, so that's positive x values. So we're looking at this piece over here, and it looks like it's approaching 0. Negative infinity over here, it's also approaching 0. All right, find all asymptotes of the function. So remember, I gave you a new definition. So let's start with horizontal. All right, the horizontal asymptote is the limit as x approaches infinity, plus or minus, of p of x. That's just 2x over 4x, which equals a half. Now, I want you to you need to actually write this. Like, you need to write that it's the limit as x approaches infinity. If you just put 2, so it's actually y equals 2. If you just put y equals 2, that's not going to count. I want you to show me that you know that it's the limit as x approaches infinity. And then for vertical, it's the limit as x approaches, what number will make this infinity. So we know it's setting the denominator equal to 0. So the limit as x approaches 1/4 of p of x from the left or the right, it doesn't matter which, let's do left, is infinity. Right, so that's going to be your answer. You could also do from the right or the left, right? The limit x approaches 1/4 from the right of p of x is infinity. Actually, one of them's negative. If I plug in 0, it's negative infinity. Just kidding. So because the limit approaches infinity at that point, x equals 1/4 is your vertical asymptote. So that's our calculus method. All right, pause the video and do this one on your own. Similar idea. All right, so the limit as x approaches infinity of p of x is 5/2. So that means y equals 5/2 is my horizontal asymptote. To find my vertical, I need to know where the denominator is 0. So let's factor that. 2x, x, let's see, 2 and 5, so it's 2, 5. So there's 2. So the limit, and the way I'm going to show this using calculus, the limit as x approaches 2 of p of x equals, I'm just going to do from the right. So that would be like 3. So that would be positive infinity. And then I could do the limit as x approaches 5/2 from the right. 5, that's 2.5, like 3. Do 3 again. That's also infinity. And that's it. Oh wait, no, I think that one's wrong. A little to the right of 2 would be 2.1. That's negative infinity. See, that's why you can't pick numbers too far away. This one's negative infinity. This one's infinity. So x equals 2 and x equals 5/2 are our vertical asymptotes because of that calculus. All right, draw a sketch of the function with the following properties. We did this a while ago. So pause the video and draw your picture. Let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 4, 5. Okay, so let's see what's happening here. So f of 5 is -1. I'm going to do it in blue. Now, it's giving me that the limit as x approaches -4 is negative infinity. So that's giving me an asymptote, right? As x approaches -4, 1, 2, 3, 4, from the right is negative infinity. So that means it's down like this. Right, so it's going like that. And then from the left, it's going to positive infinity. So over here, it's going up. And then as x approaches infinity, we're reaching 3, this. So that's a horizontal asymptote. So both directions, it's reaching, so over here it's going to 3. And over here it's going to 3. So I just have to connect this. So I'm going to just do something weird. Doesn't really matter. As long as those arrows are going in the right direction. All right, that is it. So I want you to work on your practice problems. Go in the book. Look for stuff that you're unsure of how to do. So we can talk about it on Wednesday. Have a fabulous day.